For question 8, we see the graph given is a proportional graph. It's a direct proportional. So for A, if the force of air resistance increases, which is increases upwards opposite to where the particle is traveling, so the acceleration will eventually decrease. So this is not possible. They are inversely proportional. For B, we have to think of the particle reaching terminal velocity because of falling in air for a long time. So when it reaches the terminal velocity, the kinetic energy becomes constant, half m v naught square, which is the terminal velocity, becomes constant. But when the time keeps on increasing, it is no longer a proportional because it has reached a constant value. So this is not possible. Potential energy for C is mgh, where h is the height. So we can see that as an object increases in the height, the potential energy will also increase. And this is a direct proportional. PE is mgh. So PE is proportional to h. So when the h decreases, which means the potential energy also decreases. Right? We can continue to look at D. Work done against air resistance. So we also think of this when the particle has reached the terminal velocity. So let's say the particle at terminal velocity, it is falling down, continue to fall down, and this has reached the maximum friction. We call it F naught. So the work done after it reaches the terminal velocity, W equals to F naught times D. So as the distance continue to fall, so the work done will eventually increase and increase and increase, whereas the speed has reached a constant value, so it's no longer a direct proportional. So this is not possible. Question 9, we need to recall the principle of conservation of momentum. M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. So looking at the change in momentum for mass 1, particle 1, so this will be V1 minus U1 with a negative sign. Whereas for the change in momentum for particle 2, we have V2 minus U2. So this is the change in momentum for particle 2. This is the change in momentum for particle 1, but with a negative sign there. In other words, we say that the change in momentum for particle 1 is equal in magnitude but opposite in direction with the change in momentum for the other particle. Okay? The change in momentum for one particle is always equal in magnitude but opposite in direction to the change in momentum of the other particle. Here they mention about the change in momentum of S. So first we look at it is easier to look at the change in momentum for R. So the velocity of R is in this direction, which is not exactly horizontal. It is at a small angle from the horizontal. And the final velocity also is at a small angle from the horizontal. So if we were to take the direction to the left as positive, then we will see the change in momentum for r, delta p for r will be the final velocity, which is in this direction, minus the initial velocity. So the initial velocity is in this direction. So because we have taken to the left as positive, so that the initial velocity will then be negative of that value. So if we take v minus that value, so that means it becomes plus. This is our v and this is our minus u. Because if u is in this direction, so minus u is in this direction. So v minus u will then be the resultant vector. So this is the change in the velocity. So the change in velocity, because the angle of this is very small, let's say the alpha is very small, so cos alpha is approximately equals to 1. So we can say it is simply v and minus the u, okay, which is in terms of the magnitude, it is v plus u, the magnitude. Okay, but the direction is towards the left. So the magnitude of the change in momentum, so we find out and see. So it must be m times delta v. We are talking about r first. So the mass is given as 1.0 times 10 to the power of 27 kg. 1.0 times 10 power 27, and v plus u will then be 1.0 times 10 to the power 4 plus 1.0 times 10 to the power 4 becomes 2.0 times 10 to the power 4. So that will be the change in the velocity. Multiplying these two, we get 2 times 10 to the power of 31. Okay, so now for A, the change in momentum of S. So if the change in momentum for R is in this direction, okay, this is the change of momentum of R, so it is pointing in this direction. So the change in momentum of S must be in the opposite direction. Okay, we can see the negative sign here. So this statement is not correct. It is always the opposite of the change in momentum for R. For B, the change in velocity of S is approximately 20 meters per second. So if the change in momentum for R is this much value, and this is approximate because we approximate the angle to be small, and then cos alpha is 1. All right, so they have the same magnitude. The change in momentum must have the same magnitude. So the change in momentum for S must also be having the same magnitude, 2 times 10 to the power of 31. So the mass of S is 1 times 10 power 30 multiplied by the change in velocity. So therefore, the change of velocity is approximately 20 meters per second. All right, so this is the correct answer. Well, we look at C. The magnitude of change of momentum of R is 10 to the power of 3 times greater. So this is definitely not correct. They have equal in magnitude. The momentum of R does not change, which is not correct. Okay, this is the change in momentum of R. Okay, it is this having this magnitude value. So the answer is B. All right, for question 10, we see that both trolley, after they collide, they stick together. So they move at same velocity. So if we use the principle of conservation of momentum, m1 u1 plus m2 u2, equals to M1 plus M2V. So M1 is 2, U1 is 4. So this will be 8. M2 is 4, U2 is 1. So this is 4. So M1 plus M2, the total mass when they stick together is 6V. So from here, we can get V equals to 2. So finding the kinetic energy for this, add with the kinetic energy of this, and also we find the kinetic energy of the combined, then we find the difference between them. Then we are able to get the loss in the kinetic energy during the collision. 7. So if the electric field is pointing from X to Y, we can usually denote the plate X to be the positive and the plate Y to be negative, which is at a lower potential. If the particle moves towards plate X, so it must only be the particle with a negative charge. So we say the negative will be attracted to the positive. So which of these particles has negative charge? It's only electrons. Neutron has no charge. Alpha and proton both has a positive charge. Alright, for question 12, we see here the force of F1 and F2 we can actually resolve to the horizontal and vertical component, and we take moment about the hinge here. So the horizontal force, actually the line of action of the force pass through the hinge, so the distance from the hinge is 0. So the moment due to all the horizontal forces will be 0. So we are left with this vertical force of F1 sin theta 1 and F2 sin theta 2. So this F1 sin theta 1 will produce an anti-clockwise moment, and the same also for F2 sin theta 2, it will produce an anti-clockwise moment. And the moment due to F1 sin theta 1 is multiplied by D1, the perpendicular distance, and the moment due to F2 sin theta 2 is multiplied by D2. So summing these two, it gives us the total moment due to F1 and F2. Question 13. It says the ball is rolling down at a constant speed. So if it is a constant speed, that means there's no acceleration. The net force is 0. So the system is in equilibrium. So we have always the weight acting perpendicularly downwards. The normal contact force perpendicular to the plane. And the friction always opposite to the motion. So for equilibrium, the three forces can actually form a triangle of force in a closed loop. So the force between the R and the F must also be 90 degrees. So this is the only possible answer. For question 14, we take the level here as X. So a point at this level and a point at this level must have the same pressure because they are at the same level. So this is the pressure due to the gas, and for this point, the pressure will be the pressure due to the liquid column of height 31.4 cm minus 10.2 cm, which is 0.212 meter. After you minus the centimeter, we convert it to meter. And this is the pressure due to the atmospheric pressure. So the pressure of gas on the left side must be equal to the pressure of the column, okay, the atmosphere, plus the pressure of column. We can use rho g times h. Right, so you can work out to get the answer to be 103 kilopascal.